So, in the last session, we have seen about the biomedical topic, that is aids for the handicap. So basically, that topic was all about, I mean, the help which we can provide to the handicapped people. So basically, it means that the aid which is required to carry out those daily livings or mobile activities, so which will help or improve the impaired or physical or mental function. So with the help of that, we can improve all those things. So I mean, like walking stick. So with the help of those walking stick, we can walk. So they will provide a help to that handicapped people. Like wheelchairs are there, and I've told you, like hearing aids. So these are the type of that. So basically, this the topic means that the help which we should carry in our daily living to help those handicapped persons. And for example, if we can take so suppose some example, if you are wanted to take, so we can take like walking stick. So I think everybody has seen those walking stick in your daily life. If some persons are using that, so with that help, they can move around. So wheelchairs are there. So if a person can't stand, so some problem is there, so with the help of the wheelchair, they can stand, they can sit there, and they can go anywhere around, anywhere, so where they wanted to go. Or hearing device is there. So if a person is lagging, they can't, if they're not if they're incapable of to hear anything, so with that hearing device, they can hear it. So, and it means that with the help of technology, we are helping the disabled. So basically, if I wanted to summarize this topic, so how those things are helpful. So basically, if I wanted to summarize it, I can write here. So with that help, so in one line, I can summarize that. It means that with the help of technology, we are helping the disabled. So so uh, so the disabled person, if they are unable to walk, if they're unable to run, if they're unable to speak, so for speaking, I think no device has been made now for hearing purpose. So for if eye surgery is there, then one black spectacles are there. They wear those kind of spectacles. So with that help, so these are the example of those aids for the handicap. So with these help, we can improve their daily life routine. And if I can say some of the examples from that, so if you can say aids for the daily life, so if I'll divide it into several parts. So first is aids for the daily life. So if I can take some examples in daily life. So if you have been through, so it means that in daily life, if somebody has an eating problem, so if their hands are not moving, so artificial limbs are there for them. So eating, bathing, cooking, dressing, so anything. So in this, if you can write here example for aids for the daily life, so you can write here, so which helps the disabled person for use in the activities, daily life activities, like eating, so like bathing, like cooking. So for them, any help you can provide with the help of technologies, so these are the aids for that, for them. So like dressing, so anything. So eating include, so for that, if you take utensils example of eating, you can take utensils. So utensils are also so with the help of utensils, you can put your food there, and you can eat it. So like bathing, so for that geysers are there, so they will provide you hot water. So anything, cooking, if you can take, so inductions are there. So you don't need that gas and stove. In the inductions, you can make your food. So I in all this thing, one thing is common is technology. So basically, this aids will help those people with the help of technology. And if you can take that, like some other thing, if you can take in daily life, you can take example of lift. So with the help of technology, only those lifts are moving. So automatic doors are there. So uh, uh, some sensors are there. If you can go in inox and all, so after washroom, if you will wash your hands, some sensors are there, automatic water will come. So I think many of you have seen there. So like with the help of those technology, what we are doing, we are helping people. So basically the topic means that how we are helping those handicapped people or normal people with the help of technology, how we have upgraded ourselves to help those people. So is it clear to you? I, anything you wanted to ask in this? So I mean, topic is very simple. So I've elaborated also, and I have given some examples also. So is this clear to you? ओके। सो मतलब मेरा कहने का मतलब यही है कि किसी भी हम टेक्नोलॉजी का यूज करके अगर डेली दिन प्रतिदिन लोगों को मदद कर रहे हैं, उसी को हम लोग बोलते हैं एड्स फॉर द हैंडीकैप। अगर हम लोग वॉकिंग स्टिक से चल रहे हैं, लोग अगर सीधे नहीं चल पा रहे, वॉकिंग स्टिक यूज कर रहे हैं, व्हील चेयर यूज कर रहे हैं, हियरिंग एड यूज कर रहे हैं, टेक्नोलॉजी से हम लोग लिफ्ट बनाया हुआ है। लिफ्ट अगर सीढ़ी चढ़ने की जरूरत आपको नहीं पड़ेगी, बहुत लोगों को सीढ़ी चढ़ने में दिक्कत होता है। ऑटोमेटिक ये डोर बना हुआ है, आप जाएंगे सेंसर के, आप वहां रखेंगे पैर, सेंसर के थ्रू पता चल जाएगा कोई आ रहा है तो डोर खुल जाएगा। ऑटोमेटिक लाइट होता है, अगर कोई आदमी वहां जा रहा है तो उस लाइट से लाइट जल जाएगी अपने आप। अगर आप सिनेमा हॉल में गए हैं तो हाथ धोना है तो आप आगे ले आइएगा, अपने आप पानी गिरने लगेगा। तो ये तो मीनिंग ऑफ दिस टॉपिक इज विद द हेल्प ऑफ दोस टेक्नोलॉजी वी आर हेल्पिंग दोस पीपल। अगर इफ somebody has problem in sitting, if somebody has problem in standing, so what we are introducing here, we are introducing, so with the help of those so we are using biomedical here, so biotechnology here, because electronics is also involved, and biomedical means the medical purpose, for which purpose we are using this. So we are making our work very simpler with the help of those technology. So I think this topic aids for the handicapped is completed. If you have any kind of doubt, I told you earlier also to maintain the notes. So make a notes by yourself. If you have any kind of doubt that what we wanted to add, something we wanted to add more, then you can ask me at any time. So let me add him. So actually this is the topic. So I think one more last topic is there that we will cover tomorrow. So now we will move to EMFT. So because one topic we had covered of biomedical, now one topic we will cover of EMFT. So and if some of the people who were not present in the last class, so I have WhatsApp also your marks, what you have achieved in biomedical and EMFT. So if anybody has any kind of doubt that he or she can score much, or I have given some less marks, so you can contact me after the class or anytime. Okay, sir, please check my copy one more time, and there will be more chances that your marks will be deducted because I have given the maximum mark to you. So let me move to AMFT. So, and one more thing I wanted to address here, that I will provide some notes, some theoretical notes of EMFT, and I'll provide to some of the students, and I will tell them to give to you all. So you that notes you have to read by yourself, and we will discuss it in the class. That will cover your second midterm syllabus. So if you are that we will discuss it also in the class, and if you are having any kind of doubt also, please try to read that notes, because that will be theoretical notes. What will be the theoretical terms that I will discuss here, but something will be there to by heart, that will be done by your side. So I will provide the notes before the second midterm, and that will be coming in your second midterm. So some theoretical part is there in your fifth unit for EMFT that I will provide within 1 or 2 days. So let me move to EMFT, and our today's topic is types of capacitor. So we will see how the capacitors are helpful in helpful in transferring the EMF signals. So we all are aware of capacitor. So can anybody say what is capacitor? What does capacitor generally do? So why we use capacitor means, if in one line, if somebody wanted to explain, how do you will explain what is capacitor? So since you are in third year, I think everybody is aware of capacitor. So can anybody tell me what does capacitor do? Why it is important in electronics? So can anybody tell? So please share your view. Either it is correct or wrong, that doesn't matter. So please be involved in the class. So that's all I want. So what is capacitor? What do you understand by the term capacitor? How does it is important in electronics? How does it is helpful? Why we use the capacitor? Can anybody share your view on capacitor? Avantika? For charging and discharging. Pranjali, very good. For charging and discharging, and the most important thing which is helpful for store energy. Very good. So that is what I wanted to hear. Pranjali, you are also correct. So capacitor is used for charging and discharging, and basically capacitor is used to store energy. That is the main work of capacitor. So what does it do? It will store the energy. So that energy will be used when the things are, means, suppose if charge is provided there. So suppose that is closed circuit. Suppose one close, let me show you here. Suppose one capacitor is there, and so this is the circuit here. So suppose now in the first part, what we are giving from here signal. We are giving signal from that side, so capacitor will get charge. So in the second part, if I'll do here open circuit, means if no charge will be provided in that side, so if it will be open circuit, so in that case the capacitor which had stored energy in the first time, so after not providing current also, this circuit will run, because with the help of those capacitor, the amount of energy will be stored in that capacitor, and when we will not provide current from here, so that energy will help to restart those circuit. So basically the work of the capacitor is to for charging and discharging also, and main work is for storing the energy, charging and discharging. Here I've written here. So if somebody will ask you how does capacitor is helpful, so when the circuit will go in open, so when there will be no current there, so with the help of capacitor only, that whole circuit will get the amount of current which the capacitor has stored. So for that purpose capacitor is used. So I think everybody is aware of this thing. So now I will go to types of capacitor. So let me add Amisa also. She's waiting. Now we will move to types of capacitor, because there are several types of capacitors are there. So we will मैम नहीं है अभी, आप फोन कर लो उनको. So now, so after that I will show you how those capacitors are helpful in EMF. So first of all, I wanted to tell you the basic thing about capacitor. So first types of capacitor is parallel plate capacitor. So from the name itself, it is clear that since it is a parallel plate capacitor, two sides will be there. So I will draw the figure also, the structure, how does it looks, and how it is helpful in EMFs. And from this topic, one numerical is always there, which they will ask in your RTU paper or in gate paper. So this topic is very important. So please try to concentrate, and if you are having any kind of doubt at any time, please ask me. So now we will discuss the parallel plate capacitor. So from the name itself, so since it is parallel plate, so two parallel plate capacitor will be there. So I will show you the structure of those. So basically it look like that. So in 3D I'm drawing it. So this is x-axis, this is y. So let me say this is x, this is y, and this is z. So let's suppose one plate is there. So this is one plate. I'm taking it as z is equal to 0 at 0 point, and let's suppose one other plate is there this side. So these are the two plates at z is equal to 0 at one plate, and z is equal to d. So I'm assuming d is some point. So this will be our second plate, and here we are giving positive charge. Here we are providing positive charge to one of the plate, as you can see. And let me add her also. Prativa is waiting. So here we are giving positive charge, and here we are giving negative charge. So for upper plate we are giving positive, and in the lower plate we are giving negative. And I have drawn this figure in 3D here. And the surface charge, as we are already aware, surface charge for those both capacitor will be rho s and rho s for it. So now we have taken here two capacitor, and we have introduced here, and we have given positive charge to the first capacitor and negative charge to the second capacitor. And now we are going to calculate the capacitance because of those two parallel plate. So basically, in paper, they will ask you to calculate the what will be the capacitance which will be occurred because of those two plates. So basically, capacitance means they are asking you to calculate C. So if you are aware how to calculate C, so basically, what is C? So basically, C is charge by V, charge by potential difference, Q by V. What is Q here? That is charge, and V is potential difference. So so we wanted to calculate C, and please wait one second. हेलो, अपने केबिन में आया, क्लास ले रहे हैं. हाँ, अभी मत नहीं, मत कुछ करिएगा, हम आ रहे हैं अभी, 10 मिनट में आ रहे हैं. ठीक है, हम देख ले रहे हैं, हम जा रहे हैं 10 मिनट. So now what we are going to do, we are going to calculate capacitance here, and we are already aware that capacitance is equal to charge by potential difference. So first of all, so let me say it as equation A. So now if I will calculate charge and I will calculate potential, then I will substitute those values here. So let me tell you how to calculate this. So see, we are aware that how to calculate a charge. So for charge, we are aware that charge will be surface into area. So that we have, because we had given this denoted by rho s, and rho s will be there for both terms. So we had already calculated to how to calculate charge, that is given by surface into area. So what I will write here, we are already aware of those terms. So Q is equal to rho s into A. So we find this. So now we are about to find what is V. So V will be, so one more thing I wanted to tell. So what will be the direction for this positive charge? The direction will be away from it. So I will denote a direction like this. So this is the direction for this positive charge, and and for that direction will be, for negative charge will be towards it. So anybody has any doubt why I have drawn the direction like this? So I think we have seen earlier also. So since from positive charge it will go away from it, so I have drawn away from it. So from negative charge it will come towards it. So for this will be the second. So I have drawn it because this will be coming towards it. So the direction I have drawn. So now we have calculated Q. We have got Q also. So how to calculate Q? Now we have to calculate V. And after calculating V, what we have to do? We have to substitute the value of Q and V in terms of C. So let me say it as equation 1. So how to calculate V? So for V, we are already aware that V is equal to E dot dl. So electric field into dl. And so direction of electric field will be in the minus z direction, because if I'm taking it as z, so all the electric field is going away from it. So what I will write here, minus E dot dl, and in other term I can denote it by a cap dot z. So let me write here. So electric field for this will be E1, electric field for this will be E2, and total will be E equal to E1 plus E2. So this will be the electric field for those two. So now what I'm going to do, I will substitute the values of electric field. So see, for E1, what will be your E1? So E1 will be rho s by 2 epsilon naught minus a cap z. Why I have written minus a cap z? Because since the charge is going away from it, if you can see in the figure, the charge is going away from it. So I have written, since it is z direction is in upward direction, and charge the electric current is going away from it, so I have written minus a cap z here. And this formula is, we are already aware of those. So I have written minus a cap z for E1. For E2, what I will write here, rho s upon 2 epsilon naught into minus a cap z, because if you can see here, z is in the upward direction and the charge is going away from it. So for those things I have written E1 and E2. So what I will write here, what I will get here, from there I will get, so minus rho s upon E0 a cap z. Since a cap z is common, so I've written here a cap z. Now I've got the value of E. Now what I will do, I will substitute the value of E in terms of this potential difference. So when I will substitute the value of E in terms of potential difference, what I will write here, so we are already aware that V is equal to minus E dot dl. So we have got the value of E here, that is minus rho s upon epsilon naught into a cap z. So what I'm going to do, I'm going to substitute this value to the potential difference. So are you getting it? Is there any doubt? So how I have substituted the value, how I have got those value, is it clear? So please tell, in this up to that? Okay, so it is pretty simple. If you can use your brain, you can calculate it very easily. So now what I will do, I will substitute the value of V here. So what I will write here, V equal to, बाद में कर दीजिएगा. So potential difference will be, yeah. So since it is varying from 0 to d, so what I will put here, the limit will be from 0 to d. So since it is first of all, initial value of z is 0 and final value of z is d, so it is varying from 0 to d. So I will put the limit from 0 to d, since because in the formula only I am putting the limit. So I'll put here 0 to d, and what is the value of b here? So minus rho s upon es into dz. So dl is varying from 0 to d, and that a1 a2 will become dz here. So now I will open that limit and I will find. So how to calculate it? See, you can see here. So what I'm getting here, rho s upon e0, that integration will become z, and that is varying from 0 to d. So I'll get here rho s upon E0 D, and that is our second equation. So now we have got two equation. So what we are going to do now, we will do put 1 and 2 in A, and what was our A? A was our C upon Q by V. So that was our A. So now I will put those equation in that A. So for Q we had already got. साइन करना है इसको जी, क्या करना है आगे फोटो ले ले, फोटो याद रहेगा. इसके नीचे भी है, हाँ देख ले. ठीक है. So now I will calculate here. I will put the values of Q and V there. So what I will get here, C is equal to rho s by A, and that will be divided by rho s d by epsilon naught. So if you can see that rho s will be cancelled, and what we will get here, we will get epsilon naught into A by D. So if they are asking you to find the value of parallel plate capacitor in free space, then you will get those value. If they will ask you to find the value of capacitor in dielectric medium, for that you have to multiply it by epsilon r. So I will write here epsilon naught into epsilon r into area by d. So if they will ask you to calculate how to calculate the parallel plate capacitor in a dielectric medium, for that you have to add one more epsilon r. So I think you are aware of those. So for free space, you just apply this formula. For dielectric medium, this formula will be there. So please tell me, is this clear to you? So I have derived the capacitance for a parallel plate capacitor, and based on the formula and all, we have substituted the value, and we have got this term, that is epsilon naught into epsilon r into A by D. So is there any kind of doubt in this, how I have proved and how I have substituted? So please share your views at any step. Are you finding any kind of difficulties? Distance between two plates. So why we needed to calculate distance between two plates, Amisha? So why is it necessary to calculate distance between two plates? Because since these two are parallel, so we can't. You can take it d as a distance between two plates. That will be given in the question only. Actually, I will give 10 or 5 or 6 questions from this. I will give you numerical for 5 or 6. I will share you with you because this topic is very important, and they're asking every time. Basically, three types of capacitors are there: parallel plate, coaxial, and dielectric. So from that topic, they're asking one or two question every time. Either in gate they're asking, in RTU for 8 marks they're every time they're asking. In gate also, living 1 year they're asking some questions there. So I will provide you all the numerical based on this. So first of all, I will derive all those terms. So after that, when we will go to the numerical part, that will be easy for you. So this is all about parallel plate capacitor. So if you are having no doubt, we can move to coaxial capacitor. Can we move to coaxial capacitor? So is this clear? So okay. So, Amisha, don't worry. I will provide some numerical based on that, and after that, your doubt will be more clear. One more thing I wanted to I forget here. So, if suppose this is capacitance due to two parallel capacitor, if they will ask you what is energy stored in those capacitors, so for energy stored, one formula is there: 1/2 CV square. So basically, C is the capacitance and V is the voltage between them. So if they will after in the second part, if they are going to ask you how to calculate the energy for those capacitors, so for this thing you have to apply this formula: E is equal to 1/2 CV square. And if one more, if somebody will ask you how to calculate the energy density, so energy density in capacitor, so for that, so for density we are representing it by W, and for that you have to apply this formula. So three formula I have told you. So please remember this. In the time of numericals, we can see how to calculate all those values. How to calculate voltage? Because you are very slow. We have already calculated voltage in previous lectures. So I have uploaded it on YouTube also. You can see from there. So actually voltage is potential difference between, and we have already calculated all those things. You are not present in the class, so please try to get it from there or ask your friends, they will help you. Because if I'll tell you how to calculate voltage, it will take very time. Or if you are free at any time, you can call me, I'll tell you how to calculate voltage. So because we have calculated voltage, then only we have substituted the value now. If you can see how we have calculated, so voltage is basically, what is voltage here? Minus E into dl. So this is the formula for voltage. Voltage actually potential difference. And what is E here? E is the electric field, and dl, the d is varying from where the d is varying. So in this formula only I have substituted the value. If you can see the earlier derivation. So and if any more doubt will be there, call me at any time, I'll clear your doubt. So let me move to coaxial capacitor. So three types of capacitors are there. We will see the basic of those capacitor, and after that we will solve some numericals, and I'll assure you that one or two problem will be there from those topics. So coaxial capacitor. So, and one thing you remember that before solving the problem, please read it twice, because either they are asking in free space or they are asking in dielectric medium. So sometimes student do mistakes. They are not reading the questions properly, and they are calculating it for free space, and the questions were they were asking you how to calculate in the dielectric medium. So for that, don't forget to multiply it by epsilon not r, because the value will be already given in the paper. So from there you can take. So now we will move to coaxial capacitor, and first of all we will see the structure for those coaxial capacitor, and now after that the same thing we needed to apply there, how to calculate capacitance between those two. So I will show you the structure. So first of all, how does it look like? So basically it is also in 3D figure. So if you can see, I have this is x, this is y. If I can show you, this is x, this is y, this is z. So coaxial capacitor means two wire will be there. So I'll draw here one. So this is one, and so if you can see, this is second one. So two circle will be there, two bigger circle will be there. This is one circle, and this is other circle. So basically, like this, the coaxial capacitors are looking like. So I don't know the exact figure I've drawn correct or not, but for remembrance, you can see like this. This is the length for the coaxial wire. So, and what we are doing here, we are giving a negative charge for those the small circle. We are providing negative charge here, and for the bigger part, we are providing positive charge here. So like the earlier, what we have done earlier, we are following the same steps here. So negative charge for this smaller circle and positive charge for those bigger circle. So in coaxial cable, uh, conductor will be there, small conductor and two bigger conductor will be there. Length is let me take it inner radius. The inner circle radius is as A, and outer radius I am taking it as B. So this outer radius I am taking it as B. So radius I am denoting it is by A, and outer radius I am denoting it is by B. So now the and outer conductor has having positive charge and inner conductor is having negative charge. So I think figure is clear with you. So now we are going to calculate the capacitance of those coaxial capacitor. How to calculate? So earlier also for parallel plate also we have calculated the capacitance. Now for the coaxial also we are going to calculate the capacitance. So basically how to calculate the capacitance? So capacitance is equal to charge by potential difference. So let me take it as equation A. So we are already aware. So how to calculate capacitance? We have done it earlier. So basically capacitance is charged by V. And now what we are going, now our next move is to calculate charge. So since it is in coaxial, you can see line charges are there here. We are denoting it is by L. So earlier it was surface charge. So we are denoting it by rho S. So now it is line charge. So what I will do here, I will put the value of Q. So Q will be equal to rho L into length. So why I have written here L? Because line charges are there, and earlier it was surface charges for the parallel plate capacitor. We are denoting it by rho S. Now we are denoting it by rho L. So that will be line charge into L. So and this is the first term. So I'll let me take it as equation 1. Now what? Now we will move to now we have to calculate voltage. So how to calculate voltage? So for second, voltage will be equal to minus E dot dl. So first of all, for voltage we have to calculate the electric field. How to after calculating the electric field, we have to substitute the value of voltage there, and after that we will finally calculate the value of capacitance by substituting the value of Q and V. So electric field will happen from positive charge to negative charge. So if you can see, the electric field is varying from positive to negative. So the direction will be downward because it is varying from positive to negative, means bigger in a bigger inner circle to smaller inner circle, and that will be same. So actually this circle will be in that part. So now how to calculate? So we are already aware to how to calculate the electric field due to line charge. So we have calculated in our previous class how to calculate electric field due to line charge. So we are knowing that electric field due to line charge will be equal to minus rho L by 2 pi epsilon naught into r cap. So we are already aware of those how to calculate the electric field due to line charge. We have solved several problems also based on those electric field due to line charge. So I think you are aware of this formula, rho L by 2 pi epsilon naught into r cap. We have already calculated in our previous classes, if you can figure it out. So see, so now we have got the value of E. Now what we have to do? We have to substitute the value of E. Why I have put it minus? I have to put here minus. Can anybody told me? Can anybody tell me how? Why I have put it minus here? So oh, without minus we can't write. So, are you getting it? So earlier when we have calculated the value of electric field due to line charge, we have calculated like rho L by 2 epsilon naught into r cap. So now I have substituted minus here. Can you tell me why I have put it minus here? Yes, you can tell it negative charge is present, but actually the charge is moving from positive to negative. If you can see in the figure, the bigger circle is, yeah, Amisha, you are correct, but the basic main thing is that the electric field is moving from positive to negative because one inner circle is there. Yeah, Aditi, outward direction. Why, Aditi? Aditi, why you are telling out? What is outward direction here? Don't get hesitate. Everybody, you all are correct. I'm appreciating your views because please tell me you are going in the right track. Same answer. Same answer. It will not come same. Small circle to big circle. Yeah, positive or negative because of this only, Aditi. So you are correct. So I have put it here minus. So now what I have to do? Sir, I निकल गई क्या? Sir नहीं आया कोई यहाँ. So now what I will do, I will calculate V here. So we have got the value of electric field. So now I will calculate the potential difference. So for potential difference, V is equal to limit. I will put A to B because this is A for the smaller circle and B for the bigger circle. And what I will write here, minus rho L by 2 pi epsilon naught into R into dr. So because R is varying from A to B. So now we are up to the integration only. We will do the integration and we will finish it. So what I will do? So I will integrate rho L by 2 pi epsilon naught into ln. So see, 1 by R will become ln. If you are aware, 1 by R will become ln. So this will be A to B. So what I will get here, rho L by 2 pi epsilon naught into ln B by A. So this is our second equation. So we have got two equation. What we will do now? We will put one and two in A. So after that, how to get A value of A now? See, we have got the value of 1 and 2. We'll put in A. So A will be C is Q by V. That will be, we have already calculated Q here. That is rho L into L upon rho L by 2 pi epsilon naught into ln B by A. So we have got the value of this. This is the value of V here. Q, we are already knowing that this is line charge. So rho L into L. The value of line charge will be that. So when you will calculate, so what you will get here? So that rho L get cancelled. What we will get here? 2 pi epsilon naught into L ln B by A. So this is of uh, coaxial capacitor. So we have derived two terms. So please go through the derivation because this is not sure that either numerical will be there, but sometimes they will ask the derivation also. So both derivations are same. So please, if you will solve one, you can find other. So this is all about today. We have covered up two topics. Now in the next session, we will cover one more topic and we will solve some problems that is on tomorrow. So please go through it. And if somebody is not, and please attend the classes every day because from today, regular classes will be there. One back paper is there on 10th. On that day, we will not take. Before that day or on that day, if you will tell, we will not take any class. But since we have a lot of time, please attend the classes. We are lagging on the course and we are also having the exam duty, so we are busy on that also. So whenever we are getting time, we will take your classes. So please try to attend all your classes. So that is for all today. That is all for today. And if somebody is having any doubt or anything to ask, you can remain or others can leave the class. So this is all about today. Tomorrow's class we will see other type, and after that we will solve some problem based on those types of capacitor. So thank you everybody for today's session. We will meet tomorrow.
सर ये अलमारियां रखवाओ ना इधर कचरा हो रहा है इधर इधर
सर आके ले लो, आप खत्म हो गया।